The method of images. The method of images is based on two fundamental theorems. The first one is the boundary conditions, and the second one is the uniqueness theorem. I want to give two examples. And in these two examples, I want to show how the method of images works. So imagine the first one, imagine if you have a sphere conductor and it's grounded. Now, how method image works is by placing a fake charge outside the conductor. Now, placing the charge outside the conductor, it has to satisfy a condition where the potential on the surface should be equal to 0. So it would be like the boundary. So normally when we're solving for the charge inside, we're using a lot of integrals and complicated geometry kind of ways of solving it. But the method of image does is it simplify just by placing a fake charge outside the conductor. Now, if it satisfies the voltage on the surface equal to 0, then we can apply for method of image. So essentially, what you can see this kind of sphere show as an imaginary boundary. Okay. The second example is two parallel plates. So it's kind of like a capacitor. So let's propose that if we're pointing 2-point charge outside these plates, one above and one below. Can we using method images to solve for this problem? Well, let's see. So the first one is we have to satisfy the voltage on the boundary should equal to 0, right? That's a condition. So it should be equal to 0 here and also here. So that's C. So that we have to choose a reference point. So we have to choose whether here or here. Let's choose here, right? So the voltage has to be 0 here. So in order to testify that, let's calculate using math. Well, basically the formula of potential. So if this is the reference point, so the distance from the fake charge to this, the distance would be d. And so that will be this first term. Okay, so and then from this point to the real charge, the distance is also d. So that will be this point. Now the second fake charge is here, right? And so the distance from here to here is 3d. And notice this one is negative, this one is positive, and this is negative. So these two actually cancel out and left with this part. So it's actually not equal to 0, right? So after testing, we will also have to test here, but because there's a symmetry, so we know that here will also not equal to 0. So the method of images fails in here.